Okay, so my name is Wajahid Chima. This is homework number 6, question number 2. So we're given that x and y are ID random variables with the common PDF, e to the negative x multiplied by a unit step function, e to the negative y multiplied by a unit step function. These are what the graphs look like. So for part A, we have to find the sum x plus y. And since x and y are independent, as we are given in the first statement of the question, we can use convolution for continuous random variables. So formula for convolution for continuous random variables is this right here, from negative infinity to infinity. So we're using z minus x because z equals x plus y, and then should be a y here. This should be y equals z minus x. So right here. And it goes from 0 to z. There's no negative portion of this because the function is being multiplied by a unit step function. So e to the negative x, e to the negative z minus x, 0 to z, e to the negative z dx, e to the negative z. So for x minus y, we can use convolution again. This time it's f of y, x minus z, because z equals x minus y equals x minus z. And play around with the integrals a little bit. You get 1/2 e to the z minus e to the negative z. So for part C, we have to find x times y. So this is what the graph of z looks like, and we have to find the area under. So we're using the MDF, the big F. We're going to use big F, and this is for x greater than or equal to 0 and y greater than or equal to 0. So we use big F here. The limits again, the bottom limit is always 0. This is right here, and then it's e to the negative x, e to the negative y, dy dx. Play around with the integrals a little bit, and you will get 1 plus 0 to infinity negative e to the negative x minus z of x dx. We don't have to work this out. This will be a hard integral to work out. So to find small f of z, we just have to find the derivative of big F of z. So it's 1 plus 0 to infinity negative e to the negative x minus z to the x dx, and this leads to f of z 0 to infinity 1 over x e to the negative x minus z over x dx, and this is of course for z greater than or equal to 0 for positive values. Okay, so find the quotient x over y. Use a similar process. This will be the graph. Z equals x over y equals x over z, and we have to find this area over here. So again, using big F of z, the bottom limits are 0, top limits are infinity and zy, and again e to the negative x, e to the negative y dy. Play around with the integral a little bit, you get 1 minus 1 plus z. So now again, to find the small f of z, we do the derivatives. 1 minus 1 plus z, which equals 1 plus z squared for z greater than or equal to 0. Or we could write it as 1 plus z squared times the unit step function, which will give us the positive values. And that is question number 2. Thank you for watching.